Hello everybody, so today we're going to talk about parallel lines and transversals. Okay, so lines in a plane, and remember a plane is just a flat surface. Lines in a plane that do not intersect are called parallel lines. Lines that meet at a 90-degree angle are called perpendicular lines. So here we've got an example of each. Here's parallel lines, here's perpendicular lines. Now, this right here, this little symbol, this red box in the corner here, that means that those lines, that means that angle is a 90-degree angle, which makes these perpendicular lines. These little double arrow things right here are a way that you can, this tells you that these are parallel lines, okay? So they're not just slightly off or they're going to intersect way up there or way down here. These are parallel. They're never going to touch each other. And you can have different things. You could have like one little set of arrows, or you could have three sets of arrows, or whatever. As long as you have the same number of arrows on each one, that means that they're parallel. If I have a line, like this green one, that crosses two or more other lines, that line is called a transversal. Now, the two lines don't have to be parallel, but that's when things interesting happen. If these two lines were not parallel, it would still be a transversal, but there wouldn't really be much interest going on there. Okay, so this green line is called a transversal right here. And we got it labeled T. Okay, when parallel lines are cut by a transversal, several pairs of congruent angles are formed. So, we get this situation right here. We got something called corresponding angles. Okay. Corresponding angles are angles that lie in the same position, either upper right, upper left, lower right, or lower left. They're in the same position relative to the points of intersection here. So, angle 1 and angle 5 are corresponding, and they are equal. Angle 2 and angle 6 are corresponding, and they are equal. Angle 3 and angle 7 are corresponding, and they're equal. And angle 8 and angle 4 are corresponding. They're equal. Okay, so notice here, we've got angles that have 1 mark on them. We've got angles that have 2 marks on them. So there's 8 angles, 4 of them are equal, and the other 4 are equal. Okay, so here's all of our corresponding angles, and we have a theorem that says when lines are parallel, corresponding angles are always equal. Okay, so if I have this situation here, got a couple parallel lines. They're cut by a transversal. And I have this as angle 1, and this is angle 2. Those two angles are equal. So I know that if this is 50 degrees, then I know that this one has to be 50 degrees. In fact, I know even more than that. Let's see here. Let's get these out of the way because there's basically only 2 angles here. If I knew this was 50 degrees, I know this is 50 degrees, I know this is 50 degrees, and I know this is 50 degrees. Okay? All the other angles, since this right here, this line is a straight line, that means that any 2 angles like these two that are side by side like this they add up to 180, so I know that that's 130 degrees, which means this is 130 degrees, this is 130 degrees, and this is 130 degrees. Okay, so important, when 2 lines are parallel, the corresponding angles are always equal. And what are corresponding angles? They are in the same position relative to these point of intersections. So the two in the upper right-hand corner are corresponding, the two in the upper left-hand corner are corresponding, the two in the bottom left-hand corner are corresponding, and the two in the bottom right-hand corner are corresponding. Okay, so use the information in the figure to find all the missing angles. So we pretty much just did this. So this is 50. That tells me this has to be 50. That tells me this has to be 50. And this has to be 50. It also tells me this is 130. This is 130. This is 130. And this is 130. Okay? So these two add up to 180. These two add up to 180. These two add up to 180. Those two add up to 180. Corresponding angles are equal in each position. Okay, so we can just write it out over here. Angle 1 is 130. Angle 2 is 50. Angle 3 is 130. Angle 4 is 130. Angle 5 is 50. Angle 6 is 50. And angle 7 is 130. Okay, so here's what I want you to do is I want you to pause the video here. Here's two parallel lines that are cut by a transversal. I want you to find all those angles and then jump back on here and check to see that you got it correct. Okay, so you can write it out like this. I always prefer that you write your answers on the picture, okay? Because sometimes when you do that, finding an angle will help. If you write it in the picture, it will help you find a different angle. So here I know this is 105. This is a corresponding angle, angle 3 here. That's also 105. These two angles add up to 180, so this is 75. Its corresponding angle is 75. These two angles add up to 180, so this one has to be 75, which means this one has to be 105. This one corresponds to this one. 6 corresponds to 8, so that's 105, and 4 corresponds to 2, so it's 75. So you should have got 75, 105, 75, 75, 105, 75, 105. A store owner uses pieces of tape to paint a window advertisement. The angles are slanted at an 80-degree angle, which you can see right here. So here's a line, here's a parallel line right here. Here's a transversal right here. This is another transversal over here. Okay. You're told that all these lines are parallel. You're also told that this angle is 80 degrees. How much is angle 1 right here? Well, I know that if this is 80 degrees, this angle over here would have to be 80 degrees because it's a corresponding angle. And these two angles add up to 180, so that one would be 120 degrees. So you can say that angle 1 equals 120 degrees. I'm sorry, 100 degrees. What the heck? I guess it is 1:15 in the morning, so I'm a little rummy. So this would be 100 degrees. Sorry about that. Okay, here we go. Alternate interior angles. Okay, what are they? Alternate interior angles are angles between the two parallel lines on opposite sides of the transversal. So, since they're interior, these are the interior angles in here. They're between the two parallel lines. And alternate interior angles would be angles like 6 and 3 and 5 and 4. Those are alternate interior angles, and they are the same. So angle 3 and angle 6 are alternate interior angles, as are angles 4 and 5. Now we also have something called alternate exterior angles. Exterior means outside. So if we're talking exterior, these two angles up here are exterior because they're on the outside of the parallel lines, and these down here are exterior as well. So alternate exterior are on opposite sides of the transversal. So you've got angle 7 and angle 2 are exterior, and angle, why is that not going there? Angle 8 and angle 1 are exterior. Okay, so we've got that right here. And we now have a couple of theorems. When lines are parallel, alternate interior angles are always equal. So that's saying that 4 and 5 will always be equal, 3 and 6 will always be equal. And when lines are parallel, alternate exterior angles are also equal. So 1 and 8 are equal, 2 and 7 are equal. Now, all these theorems work when these lines are parallel. If they're not parallel, then none of that is true. Okay, the photo shows a portion of an airport. Describe the relationship between each pair of angles. So angle 3 and angle 6. So angle 3 would be this angle right here. Angle 6 would be that angle right there. Those would be alternate exterior angles. And we know that if these two lines are parallel, which they are, it shows a little parallel sign right here and right here, then angle 3 is equal to angle 6. Okay, let's look at angle 2 and angle 7. So angle 2 is right here, and angle 7 is right here. Those would be alternate interior angles. And since those lines are parallel, angle 2 has to equal angle 6, or angle 7, sorry. Okay, so here you go. We got a little assignment for you, 1 through 29 odd, that we'll do in class next time, and I will see you guys later.